M1 Kinematics, I'm just going to quickly run through the algebra in section 2.2 here to make sure that you understand how we can derive some of the Suvat equations from the other Suvat equations. So the ones we've used up to now in examples 1 to 4 are V equals U plus AT and S equals U plus V over 2 multiplied by T. We're going to derive these other three using algebra. Now if you look at the first one, this one doesn't have a t. So the t has been eliminated between these two equations. And it tells you how to do this down the side. So first thing, we've got to rearrange this formula to make t the subject. So we'll do that in two steps. I'll take the u over first of all, and then I'll divide through by a. And that will give us an expression for t. I can now substitute that expression into here. So we'll have u plus v over 2. And then instead of t, I'm going to put this new expression for t. Now that looks quite complicated, but if we do some multiplying out and rearranging, remember when you multiply fractions, you multiply the numerators together and you multiply the denominators together. Well, denominators are easy. I'll do that first. Let's have a look at the numerator. So we've got uv from the first pair minus u squared plus v squared and minus uv. Now that last term there and the first term, they'll cancel because they're both the same. And then if I just put these the other way around, so we've got the positive quantity at the front, that tends to be how we write things. Okay, so that's an expression for S. Now if we just rearrange to get it into this format, so the v squared is at the front, so if we cross multiply the 2a, multiply by 2a on both sides, we'll have 2as equals v squared minus u squared. And then if I bring the u squared over, you've got u squared plus 2as equals v squared. And that's this formula here, the first one. So that's the first one proven. We've eliminated t and we've got an expression that doesn't involve t. Okay, let's move on to the next one. So we've got to, for this one, work out s equals ut plus a half at squared. That was the second equation we were going for. Now if you look at this one, the one that's missing is v. So we're going to try and get rid of v. What we can do is we've got an expression here for v. I'm going to substitute it into this one, into the second one, and see what we get. So s equals u plus, instead of v, I'm going to put this quantity here, because that's equal to v. Divide it by 2 and multiply by t. So let's see what we've got. Well, you've got 2u at the beginning and at. That's all divided by 2 and multiplied by t. The t is with the numerator, so if I multiply that out, we'll get 2ut plus at squared, and we'll divide it by 2. Now all of those terms, both of those terms on the numerator are divided by 2. So if I divide the first one by 2, that just gives us ut. 2 divided by 2 is 1. And then the second one is divided by 2. Now if you imagine that this is a 1 here, at squared means one lot of at squared. So 1 divided by 2 is a half. And that's how we get that fourth formulae. The 4 up to now you definitely need to learn. There is one last one which we're going to prove here. The last one I'd say is the one that's used the least, and actually by using the other formula, you can get away without knowing this one, but it's up to you. If you want to learn it as well, then you've covered all the bases. So in this one we haven't got the u, so we're going to do the same thing as we did earlier. If you start off with the formula v equals u plus at, you can rearrange that and you can say that v minus at is equal to u. So we've got an expression for u, and now we can eliminate it. So I'm going to substitute this expression into the equation we've just proven. So s equals, instead of writing u, I'm going to write this v minus at. That's multiplied by t, we're doing ut, plus a half at squared. So if we just sort out the algebra here, I'll multiply out the first bracket, so it's vt minus at squared plus a half at squared. Vt is okay. Now these are the same kind of term. Minus at squared means minus one lot of at squared. If you then add on half of an at squared, minus one add a half is minus a half. And that gives us that fifth equation.